Okay. Right now. So in yesterday, so we completed atomic structure, classification of elements. So based on the classification of elements, so already I had given some of the questions also, how they're asking the question. Especially they're asking the questions based on ionization enthalpy, okay, and electron negativity and electron affinity. Based on these three concepts, they're asking the questions. And what is the other concept they're asking the questions means here, based on ionic radius and atomic radius, increasing orders and decreasing orders only they're asking the question. Okay, so any doubts are there in that one? So this part is very, very important. This part is very, very important for the exam point of view. Okay, so if it is not there, then I'll go for the next new chapter. So what is the new chapter I'm going to start means here, chemical bonding. Okay, so chemical bonding I'll start. Start as here. Next we have a topic is here, chemical bonding. In chemical bonding, so what are the main concepts we're having based on the JEE examination means here? One is molecular orbital theory they're asking, dipole moment they're asking, okay, and hybridization and all they're asking. Hybridization, VACPR theory, both are interlinked, it is that, okay, and valency bond theory. So valency bond theory is different, it is that, okay, and remaining based on the ionic bond, covalent bond, coordination covalent bond at all types of the bonds they're asking the questions. Okay, now first we'll discuss about the types of the bonds. How many types of the bonds are there? First, tell me fastly. How many types of bonds? Types of bonds. How many types of the bonds are there? How many types of? Four types. What are the four types of the bonds we are having, ma?
Ionic bond, covalent bond, metallic bond, and hydrogen bond.
Hydrogen bond. So actually, in this chapter, we are going to study about here ionic bond, covalent bond, ionic bond, covalent bond, coordination, covalent bond, covalent bond. Okay. In this one, first of all, what is meant by the ionic bond? So how many members are having clarity, ma? So what is meant by the ionic bond? Every time we are studying ionic compounds and at all, what are the properties? What is meant the ionic bond? So what is meant the ionic bond means here, the electrostatic attraction forces present in between oppositely charged ions are called as a ionic bond. Okay. So what is meant the ionic bond, ma? The electrostatic attraction forces. Electrostatic attraction forces. Electrostatic attraction forces are present in between oppositely charged ion. Oppositely charged ions. Charged ions are called as a ionic bond. And we can give another definition also. So what is meant the ionic bond means here? Ionic bond is nothing but is the bond which is present between the metal and non-metal is called as a ionic bond. Okay, the ionic bond is going to be explained here. The bond is going to be explained between the metal and non-metal. Okay. So the bond which is present between the metal and non-metal also we can call as here ionic bond. Sir, what are the examples for the ionic compounds means here? NaCl, KCl, KNO3, NaNO3, NaNO3, Na2SO4. So all these are the examples of ionic bonds. All these are examples of ionic bonds. So now you got the clarity here. Okay. And what are the factors favors the formation of the ionic bond? Sometimes they're asking what are the factors favors the formation of ionic bond. Which factors are favor the formation of the ionic bond means here? Size of the cation. Size of cation. Greater the size of the cation, greater the ionic in nature. Okay, size of the cation. Greater the size of the cation means larger, greater the ionic character. Okay, and electronegativity. How much negative charge it is there? Electronegativity is going to be increases. Formation of the ionic bond also is going to be increases. That means size of the anion also is greater. For example, here size of the anion also greater means that it forms as a metallic bond. That's an ionic bond. Okay, now you got the clarity here. And what is another factor is going to be explained means here. One is ionization enthalpy. The atoms which are having low ionization enthalpy, they exhibit as an ionic bond. The elements which are having low ionization enthalpy, they form as an ionic bond. Sir, what are the best example in a whole periodic table? Which elements are having low ionization enthalpy means here, alkali metals are having low ionization enthalpy. Okay, so which one are having low ionization enthalpy? Alkali metals are having low ionization enthalpy. Clear? Okay, alkali metals are having low ionization enthalpy. Okay, and which are having highly electronegative atoms here? Halogens only, na? Halogens are they having here highly electronegative. Okay, so that's why the bonds which are present between the alkali metals and alkaline, and that means halogens are called as here ionic bonds. Okay, clear? Greater the electronegativity, greater the ionization enthalpy, lowest the ionization potential value. Okay, that is also one of the important factor to form the ionic bond. Okay, and what is mean by the covalent bond? What is mean by the covalent bond? How we can define as a covalent bond? What is mean by the covalent bond? What is mean by the covalent bond?
Sharing of electrons.
Very good, ma. So mutual sharing of electrons between two atoms is called as a covalent bond. Okay, mutual sharing, that means giving and taking here. Okay, mutual sharing of electrons in between two atoms is called as a covalent bond. In the formation of the covalent bond, how many electrons are required? In the formation of one bond, two electrons are required, ma. Okay, so in the formation of the one bond here, how many electrons are required? Two electrons. That's why mutual sharing of electrons between two atoms is called as here covalent bond. Okay, here, sir, we have two types of the covalent bonds are there. How many types of the covalent bonds are there here? Two types. So one is called as a polar covalent bond, polar covalent bond, and non-polar covalent bond, and non-polar covalent bond. Covalent bond. Sir, which one we can call as a polar covalent bond means here the covalent bond which is present in between. Okay, the covalent bond which is present in between two electronegative atoms, highly electronegative atoms is called as a polar covalent bond. So, for example, what we can are the bond which is present in between two different atoms also we can call as a polar covalent bond. Sir, what are the examples of the polar molecules means here? Water, ammonia, NH3, HF, HCl. All these are the examples of the polar covalent molecule. Sir, how you are telling that all these are the examples are the polar covalent molecule means in water molecule, The covalent bond is present between the oxygen and hydrogen. Oxygen and hydrogen both are identical atoms or different atoms, ma? Both are different atoms only, na? So based on that one, what we can say, the bond which is present in between two different atoms is called as a polar covalent bond. Sir, what is the non-polar covalent bond? Non-polar covalent bond is nothing but the bond which is present in between two identical atoms is called as a non-polar covalent bond. In that one, the net electronegativity becomes as 0. Okay, the net electronegativity difference you will get as a 0. Okay, what are the examples means here? Hydrogen. Okay, hydrogen. Here, nitrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So all these are the examples of the non-polar covalent molecules. Okay, some molecules are there. They contain the polar covalent bond as well as non-polar covalent bond also. Okay, some molecules are they're having polar covalent bond as well as here non-polar covalent bond. So, sir, what are the examples for that one means here? Some compounds are having polar and non-polar. What is the example means hydrogen peroxide? If you see hydrogen peroxide is containing polar covalent bond as well as here non-polar covalent bond. Sir, which one we can take as a polar covalent bond means the bond which is present between the oxygen and hydrogen is called as a polar, and the bond which is present in between two oxygen atoms is called as a non-polar. Okay, so what are the characteristic properties of the covalent compounds? What are the characteristic properties of the covalent compounds? Okay, already you studied hydrocarbons, organic chemistry, and at all. All are the covalent compounds only. Organic chemistry means here it is for covalent compounds only. What are the characteristic properties of the covalent compounds, and is any examples are there? Most of the covalent compounds are, they may be gases, liquids, or solids also it is there. Okay, and covalent compounds are insoluble in water. Covalent compounds are insoluble in water. Sir, what are the examples for the insoluble in water means here? One. What are the examples means here? Hydrocarbons. Is hydrocarbons are soluble in water or insoluble in water? Hydrocarbons. Hydrocarbons are insoluble in water only, na? Sir, what are the examples of the hydrocarbons? Means petrol, diesel, kerosene, all these are the examples of fuels. Whatever the fuels we are using, all those are the hydrocarbons only. Okay, LPG cylinder also it is a hydrocarbon only. Is hydrocarbons are they soluble in water or insoluble in water?
Insoluble.
Insoluble. Petrol, diesel, kerosene, and all they are insoluble in water. Okay, clear? Right. So hydrocarbons are insoluble in water. Covalent compounds are insoluble in water. But some covalent compounds are there. They are highly soluble in a water. Some covalent compounds are they are highly soluble in a water. Sir, what are the example for that one means here? Glucose. Glucose is a covalent compound, and urea also it is a covalent compound. Glucose and urea are the both are covalent compounds only, but both are soluble in a water. Soluble in water. Sir, why they are soluble in a water means because of they form as a hydrogen bonds. They form hydrogen bond. They form hydrogen bonds. They form here hydrogen bond. Number of hydrogen bonds are increases. Their solubility also is going to be increases. Due to that reason only glucose is highly soluble in a water. Okay, and urea also it is highly soluble in a water. But same concept already you studied in 12th standard. Alcohols, phenols, ethers we studied. Aldehydes, ketones, carboxylic acid we studied. Amines also we studied. Amines, aldehydes, ketones, carboxylic acid, alcohols, phenols, ethers also covalent compounds only. But there we studied some common statement. In all the chapters, what is the statement we studied means here? Lower alcohols and lower aldehydes and ketones, lower amines are soluble in a water. If the carbon chain length is increases, solubility is going to be decreases. Why the solubility is going to be decreases means because of hydrophobic, that means carbon chain length is non-polar. Non-polar character is going to be increases. Non-polar character is going to be increases means automatically solubility is going to be decreases. Okay, so here also what happened, glucose and urea. Glucose and urea both are here covalent compounds, but due to the presence of the hydrogen bond, they are soluble in a water. Okay, and what are the other characteristic properties? These covalent compounds are the good conductors of electricity or bad conductors of the electricity? The
Bad conductors.
bad conductors of electricity. Okay, bad conductors of electricity. Ionic compounds are that they act as good conductors of electricity, but in solid state they act as a bad conductors of electricity. Okay, electricity, bad conductors of electricity. Ionic compounds are they conduct the electricity in the form of ions. Covalent compounds are they conduct the electricity in the form of electron. Okay, sir, you are telling that bad conductors of electricity. What is the best example for the bad conductor of electricity and which is a known covalent compound means diamond. Okay, we all knows diamond. You knows or not? So diamond is a allotropic form of the carbon. Carbon is a covalent compound only. So what are the bonds present in between the carbon and diamond? All are covalent bonds only. Okay, so the diamond also is a covalent compound. It is insoluble in water. Okay, at the same time it acts as a bad conductor of electricity. Why it acts as a bad conductor of electricity, ma? Because of in diamond each carbon is exhibit as a sp3 hybridization. There is no free electron. There is no free electron. So due to that reason only diamond it does not conduct the electricity. But in this one only one more allotropic form is there. So graphite is it act as a good conductor of electricity. Graphite is acts as good conductor of electricity. Acts as here good conductor of electricity. So why the graphite is it act as a good conductor of electricity means because of in graphite each carbon exhibit as a sp2 hybridization. Each carbon is exhibit as a sp2 hybridization. Okay, and each carbon is having one unpaired electron. That unpaired electrons are involved in a conductivity. Okay, so that's why graphite is a good conductor of electricity. Clear? Okay, and so these are covalent compounds are having high melting points and boiling points. They're having here high melting points and boiling points. Okay, sir, what is the best example for that one means diamond. Diamond is having the highest melting point. Now, so what is the melting point of the diamond means diamond is going to be melt more than 2000 Kelvin. Okay, more than 2000 degrees Celsius temperature. At what temperature they are going to be convert means here, whenever you are going to heat more than 2000 degrees Celsius temperature, that the diamond is converted into graphite. Got it all of you? Okay. So these are the properties. These are the properties of covalent compound. And what is the coordination covalent bond? Here only one more concept is that it is nothing but Fajan's rule. Fajan's rule. What is mean by the Fajan's rule? What is mean by the Fajan's rule? It comes under the covalent compounds only. So what is mean the Fajan's rule means Fajan's rule is explained percentage of the covalent character. Percentage of covalent character, or it explains the percentage of the ionic character also. Okay, sir, why we are using as a Fajan's rule means here whatever the bond it is that no bond is 100% covalent and no bond is 100% ionic. Okay, no bond is 100% covalent or no bond is 100% ionic in nature. Okay, sir, why means here some Fajan's rule they had given rule how we can find out the covalent character and at all means let us see. First of all, smaller the size of the cation. Okay, smaller the size of cation, greater the covalent character. Greater the covalent character. Greater the covalent character. Okay, so what are the examples for this one means here? For example, I had given as a lithium chloride and potassium chloride. So lithium chloride also it is there, and potassium chloride also it is there. If you compare with the lithium chloride and potassium chloride, so which one is highly covalent in nature means here lithium chloride. Sir, how you are telling that lithium chloride is having the high covalent in nature means here because of smaller the size of the cation. Okay, so because of smaller the size of the cation. Okay, but here larger the size it is there. Larger the size means it has a greater the ionic character, but not the covalent character. Okay, now second condition. So what is the second condition means here? Larger the size of the anion. Larger the size of anion. Okay, now if you compare in this one, lithium chloride and lithium iodide. So if you see the lithium chloride and lithium iodide, so which one is having the greater the covalent character means here lithium iodide. Okay, sir, how you are telling that lithium iodide is having greater the covalent character? Covalent character can be explained based on the polarizability. Okay, it is explained here polarizability. One more concept is that. Sir, what is meant by the polarizability means here distraction of electron cloud around the anion with the cation is called as a polarizability. Sir, if you see iodine is having larger the size. Iodine is surrounded by the 7 unpaired electrons. Okay, how many electrons are there in the valency shell means here 7 electrons are there. So lithium is having their outermost orbital is having 1 electron. It is having here 1 electron. Okay, it is having 1 electron. Now, when the lithium is anion is strongly attracted to the smaller the size of the cation only now, because of your positive charge is there. Here fully negative charge it is there. Okay, so in between these two, if it gains the electrons means iodine becomes as a negative, and smaller the size means it is easily distract the electrons around the iodine. Okay, the possibility of the distraction of the electrons around the iodine is called as a polarizability. Polarizability character is going to be increases, covalent character also is going to be increases. Got it? Second one, next one. Here, greater the charge of the cation, charge on cation and anion. Greater the charge on the cation as well as anion. The greater the charge on the cation as well as the anion means covalent character also is going to be increased. Okay, for that one I'll give one example. Here, sir, we had taken as a sodium chloride, magnesium chloride, MgCl2. Okay, we can take as a AlCl3. So which one is having the greater the covalent character? Which one is having the greater the covalent character? Either sodium chloride or magnesium chloride or aluminum chloride. Javian, which one is having the greater the covalent character?
Sir, chlorine, right? Chloride.
Which all are chlorides only, ma. Which chloride is having greater the covalent character?
NaCl.
NaCl. I think so. Statement is missing. Greater the charge on the cation or anion?
Sir, AlCl3.
AlCl3. Sir, how you are telling that AlCl3 means what is the charge of the aluminum? Means aluminum is having +3 charge. Magnesium is having +2 charge. Sodium is having +1 charge. Positive charge is going to be increases means covalent character also is going to be increases. Now we got the clarity.
Yes, sir.
Okay, so this is a concept. And so we have a one more word, pseudo inert gas configuration. Pseudo inert gas configuration. Pseudo inert gas configuration. Gas configuration, sir. Sir, what is meant by the pseudo inert gas configuration? Sir, what is meant by the pseudo inert gas configuration means here the element which is having 18 electrons in their outermost orbital is called as a pseudo inert gas configuration. The elements which exhibit pseudo inert gas configuration that also exhibit as a covalent character. Sir, what is the best example means here? Zinc chloride. So zinc chloride is little bit covalent character. It is that one. Sir, how you are telling that zinc chloride is having the greater the covalent character? So why it is having the greater the covalent character means, let us see. one thing I'll tell. Calcium chloride, if you compare with the calcium chloride and zinc chloride. So zinc chloride is having pseudo inert. So Zn plus 2. Zn plus 2 means how we can write the electronic configuration, outermost electronic configuration 3s2, 3p6, 3d10. So total how many electrons are there in third energy level? Total how many electrons are there, ma? 18 electrons are there. D orbital 10, p orbital 6, and s orbital 2. Total number of electrons is equal to 18. The element which is having 18 electrons in their outermost orbital is called as a pseudo inert gas configuration. Got the point? So the elements which are exhibit as a pseudo inert gas configuration, they also exhibit as a covalent character. Based on this one also, sometimes they're asking the questions. Okay. Next, we'll go for the coordination covalent bond. Go for here. Coordination covalent bond. So what is meant by the coordination covalent bond? Coordination covalent bond. Coordination covalent bond. So what is meant by the coordination covalent bond, ma? What is meant by the coordination covalent bond? Sharing of lone pair of electrons in between two atoms or molecules is called as a coordination covalent bond. So what is the coordination covalent bond, ma? Sharing of lone pair of electrons between two atoms or molecules is called as a coordination covalent bond. And we can give another definition also. The bond which is present in between Lewis acid and Lewis base. Lewis acid and Lewis base. The bond which is present in between Lewis acid and Lewis base also we can call as a coordination covalent bond. Sir, which one we can call as a Lewis acid? What is meant by the Lewis acid? Lewis acid is nothing but electron deficient molecules. What are the examples of the electron deficient molecules? Means here the molecules which are having the 6-state configuration. That means BCl3, BF3, BBr3, okay, AlCl3, FeCl2, okay, SnCl2. So all these are the examples of electron deficient molecule. And Lewis bases. So what is with the Lewis bases means here the molecules which have a tendency to donate the lone pair of electrons is called as a Lewis bases. The molecules which have a tendency to donate the lone pair of electrons is called as a Lewis bases. Okay, and here, sir, what are the examples for the Lewis bases? Means NH3, sir. Okay, NH3 and H2O, water molecule, and primary amine, R bond and H2. All these are the examples of the Lewis bases. Okay, so what is the best example for the coordination covalent bond? Means here, best example is here ammonia and BF3, NH3 and BF3. So BF3 is having the one vacancy p orbital, and nitrogen is having the one lone pair of electron. So whenever the donates the lone pair of electron, NH3, the lone pair donation of lone pair of electrons can be represented with arrow mark. Okay, and towards to the vacancy orbital. So in this one, covalent bond and coordination covalent bonds, the two are we can call as a directional bonds. And ionic bond is called as a non-directional bond. Ionic bond is called as a non-directional bond. So which one are the directional bonds, ma? Covalent bond and coordination covalent bonds are both are directional bonds. Okay, now we got the clarity. And what are the properties of the coordination covalent compounds? Any one of you? What are the coordination covalent compounds? Properties of the coordination covalent compounds, ma? The properties of the coordination covalent compounds are similar to the covalent compounds only. Okay, they are insoluble in water, they are the bad conductors of the electricity, okay, and they're having high melting point and boiling point. Sir, what is the special property in this one? Means here coordination covalent compounds are having high melting points and boiling points while comparing with the covalent compounds. Got the point here? Coordination covalent compounds are having high melting and boiling points by comparing with, okay, by comparing with here covalent compound. Coordination covalent compound also they consider it as a covalent bond also. Coordination covalent bond also they consider covalent bond. Now we got the clarity. Covalency we are using one word. What is mean by the covalency? Covalency. What is mean by the covalency? For example, they're asking one question mark. What is the covalency of the nitrogen in ammonia? What is the covalency of nitrogen in ammonia? Any one of you? What is the covalency of nitrogen in ammonia? That means how many bonds are there between the nitrogen and hydrogen? Nitrogen is going to be formed how many bonds with the hydrogen atom?
3 bonds.
3 bonds are there. Okay, how many bonds are there, ma? So 3 bonds are there. So hence the covalency of the nitrogen is equal to 3. Hence the covalency of the nitrogen is equal to 3. Clear? Okay. So this is about the types of the bond. Okay. So after that, what is the main important concept? Next important concept we are having means here. So next we will discuss about hydrogen bond. Okay. One more easiest concept only here. Hydrogen bond. Hydrogen bond. So remaining concepts I'll complete tomorrow. The hydrogen bond. Now what is meant by the hydrogen bond means the weak electrostatic attraction forces. Weak electrostatic attraction forces. The weak electrostatic attraction forces present in between highly electronegative atom and positively charged hydrogen is called as a hydrogen bond. So what is meant by the hydrogen bond means here? The weak electrostatic attraction forces present in between highly electronegative atom and positively charged hydrogen atom is called as a hydrogen bond. Sir, what are the electronegative atoms we are taking means? We are taking only nitrogen, oxygen and fluorine. We can't take as other elements. All these 3 only it is going to be. These 3 elements are only it is involves in the formation of the hydrogen bonds. Hydrogen bonds can be represented with dotted lines. How we are going to represent the hydrogen bond, sir? Hydrogen bond can be represented with dotted lines. Hydrogen bond is stronger than the van der Waals forces here. Hydrogen bond is stronger than that of here van der Waals attraction forces. Okay, hydrogen bond is stronger than that of van der Waals attraction forces. Clear? Here, how many types of the hydrogen bonds we are having means we have 2 types of the hydrogen bonds. How many types of the hydrogen bonds are there? 2 types. So one is we can call as a intramolecular hydrogen bond. Intramolecular hydrogen bond. Another one is called as here intermolecular hydrogen bond. Another one is called as here intermolecular hydrogen bond. So what is meant by the intramolecular hydrogen bond? Intramolecular hydrogen bond. So what is meant by the intramolecular hydrogen bond means the bond which is present within a molecule, the hydrogen bond which is present within a molecule. The hydrogen bond which is present within a molecule is called as here intramolecular hydrogen bonding. Due to the presence of the intramolecular hydrogen bonding, melting points and boiling points are going to be decreases and solubility also is going to be decreases. Solubility also decreases. Okay. Now, sir, what is the intermolecular hydrogen bonding? What is the intermolecular hydrogen bonding means? The hydrogen bond which is present in between 2 different molecules. two different molecules is called as a intermolecular hydrogen molecule. Okay, intermolecular hydrogen bonding. Okay, due to the presence of the intermolecular hydrogen bonding, first solubility is going to be increases. Solubility is increases. Melting points and boiling points also is going to be increases. Melting points and boiling points also is going to be increases. Okay, so based on that one, some questions are there. So which questions we are having means already studied in alcohols, phenols, ethers. In phenols, we have a orthonitrophenol, paranitrophenol is there. Orthonitrophenol and paranitrophenol can be separated by the steam distillation method. Okay, orthonitrophenol and paranitrophenol are separated by the steam distillation method. Okay, sir, why we are separated by the steam distillation method means here because of this one is called as orthonitrophenol. In orthonitrophenol, it has an intramolecular hydrogen bonding. It has here intramolecular hydrogen bonding. Then whatever the paranitrophenol means here, in paranitrophenol, NO2, and another one is here, write as here OH. Okay, this interlink here NO2. Okay, NO2. It forms as a intermolecular hydrogen bonding. That means the number of molecules are increases, number of bonds also is going to be increases. Number of bonds are increases, their melting point temperature also is going to be increases. So due to the boiling point temperature also is going to be increases. Due to that reason only, orthonitro and paranitropenols are separated by the steam distillation method. Okay. Which one is having the greater the melting point, the greater the boiling point temperature means paranitrophenol is having greater the boiling point temperature while comparing with the orthonitrophenol. And one more JEE question. So what is the another JEE question means chloral hydrate is stable or unstable? CH3, CHO, H2O. This we can call as a chloral hydrate. Is chloral hydrate is stable or unstable? It is highly stable. It is highly stable. Sir, how you are telling that it is highly stable means here in this one, can check it out. Here O, here Cl it is there, here Cl it is there, here Cl, here O bond H, here O bond H. That means here also intermolecular, here one. Then this one is attaches with the hydrogen. Okay. Now, how many hydrogen bonds are formed? So in between two hydrogen chlorine. Here also hydrogen chlorine. You may get the doubt. Sir, you told that only nitrogen, oxygen, fluorine only involves in a hydrogen bond. Then in this case, you are taking as a chlorine. Yes, ma'am. Okay. In only chloral hydrate only, we have to take as a chlorine. In other molecules, we can't take as a chlorine. This is an exception case. This completely exception case. Okay. So whenever it is involves the hydrogen bonding means it forms as a two cyclic rings. The formation of the cyclic rings only we can call as a chelation. Number of cyclic rings are increases. Their stability also is going to be increases. Number of cyclic rings are increases. Their stability also increases. So due to that reason only, chloral hydrate is highly stable. Now we got the clarity. All of you
Yes, sir.
understood? Okay. So based on this one, you are having some of the questions. Okay. Already in group, I forwarded some previous year questions. So once you go through that one, remaining somewhat important questions, concepts are there which is related to JEE that we are going to be discussed. Okay. Thank you
Okay,
all.
sir.
We'll continue in the tomorrow class. All of you
Thank you,
understood
sir.
now until here?
Yes, sir.
Yes, sir.
Okay, right.